Hi, I'm Tanya Janka, and I wrote a book, Alice and Bob Learn Application Security. And this stream is the first of 11 streams where we are going to talk about each of the chapters in the book. Specifically, at the end of each chapter, I have a whole bunch of questions that I ask the reader to think about. And I have an answer key, but the answer key is lame on purpose. It's very short. And the reason is because I wanted to hold these discussions. And quite frankly, because I wanted to invite a whole bunch of other experts on so you could get multiple opinions. If you did not read the book, that's okay, because we're going to talk about a lot of the things. If you did read the book, though, if you want to try to answer some of the questions with us in the chat or ask more questions, awesome. So let's introduce my guests. Can we bring them all out? Awesome. Thank you so much for coming, all of you. So I'm hoping that we could do a roundtable. Maybe I should introduce myself, because what if people are watching and they don't know me? That did not occur to me. So I'm Tanya Janka, and I'm known also as SheHacksPurple. And I am a dev that turned into a security person who loves AppSec, which is the place in the middle where security and devs meet and hopefully get along. Dominic, do you want to go next?
Yes. Thanks for the invitation. My name is Dominic. I work in AppSec since 2011. And like Tanya, I start my career as the development world. Sorry for my accent because I'm a French speaker, so I apologize. And after few years, I decided to switch to the application security in order to make the bridge between the two worlds. Try to make the bridge in the best I can. So same like Tanya.
It's true, right? Like, it's a really good path to take into our field is being a dev first, but you don't absolutely have to be a dev to be awesome at AppSec. It's just like you get this extra head start on everyone else. Ray, do you want to go next?
Yeah, I'm Ray LeBlanc. I'm an application security architect. I work in healthcare currently, but I also got my start as a developer. I currently write for hellasecure.com with my friend Aaron. So I guess check us out. We have some interesting stuff on there.
Awesome. Okay, so up next is Ron Brash. Ron, can you tell us a bit about you?
Hello. So funny for the audience, Tanya and I we frequent the same circles and we haven't managed to run into each other. So it's kind of fun to be, virtually meeting in person. I come from a very different background than most people. I come from industrial control systems and critical infrastructure. But I actually started off more on the IT, plugging in things and then doing technical destruction of systems and software. And then I ended up going to school and then going down the software development path. And then I became very entrenched in security because of what we do in our industry. So my path is very different than many other people's, but I'm hoping that, we'll have a great conversation today.
Awesome. I'm super pumped. Part of why I wanted to have so many different people on is specifically to get lots of different opinions, because this book is literally my opinion with the support of my two technical basically, I had two technical editors, and one was Eli Sad, and the other one was Dominic, which is why I was really grateful that he would be on here. So I was hoping we could go through some of the bigger things in chapter 1 and talk about them a little bit, and then go into the questions. Does that work for everyone? So, the book starts with pushing left, which I feel is like a bit of a jump at the beginning. I can't remember exactly why. I was like, I need to tell them this first. Shifting left, pushing left, we must do this. Does anyone want to talk about what we mean by that? Like when we talk about shifting left or pushing left? I know you're all like, I know the answer.
No. I will start and try to little bit. In fact, as in my career, I have often seen, and today, unfortunately, often the security are arriving at the end of the development cycle, like, for example, penetration test at the end and so on, so code review. And for me, it's like roll the dice, because perhaps you will find nothing, and perhaps it will be the hell. And most of the time, the hell is for developers because it's up to them, unfortunately, to fill the hole and so on. So for me, pushing left, it's introduce security in each step of the project, depending on the customer, the culture, and there are no one solution for all, but try to introduce security steps in every part of the project in order to let's like water flow around the flower, for example. It's just my point of view.
Yeah. Ray, could you tell the audience, just in case they don't know, like what the system development lifecycle is?
Let's see if I can remember it.
Well, no, not the steps, but just like it's a process that devs need to follow, or otherwise there's no code
okay.
at the end.
Yeah, I mean, it's from requirements onwards to deployment, right? So, it's the steps that every software has to kind of go through, whether it's formalized or not. There is like, I have an idea, and that could be super formalized or not, all the way to my code is now running in production, and it basically covers everything in between. So.
Yeah, exactly. And so, yeah, I think like part of the pushing left thing though is also, so I show a picture of it. Nancy, I'm going to for a second put the pushing left image on the screen that I think we have that is in banners because I'm looking in the wrong place. So Nancy's showing me how to do all sorts of things in StreamYard, and she's like the amazing, awesome human that does all the things. Oh, and I picked something not in chapter 1. So it's in the intro before chapter 1. So there's no image, but that's okay. But basically the system development lifecycle, whenever we write it, it's like a picture, right? It's like you will do requirements, then you will design it, then you will code it, then you will test it, then you will release it. And it doesn't really always happen like that. But when you write left, so the way that Anglophones write, or even people like in romantic languages, we write left to right on paper. And so when you go left on the page, you're earlier in the system development lifecycle. And I don't know who named that, but they're like, we want to shift left, we want to push left, we want security from the beginning until the end. And I remember a person showing it to me on paper, and it was like this huge light bulb went off for me. I was like, oh my gosh, shifting left, you mean like physically shifting left in this image, like the idea? Because I remember thinking like, you don't code on left or right, like, yeah. Exactly. Okay, so I was wondering if next we could talk about the security mandate of CIA, like confidentiality, integrity, and availability. And I feel like Ron probably is like, I know that inside and out, but are you interested in explaining like what C or I or A or all of it is, or how that's why we have jobs?
Oh, well, absolutely. So maybe I'll circle back to a little bit before about the pushing left. So depending on which type of programming you're doing, and if you're doing embedded, and if you came from microcontrollers, you do shift left. We do things called bit shifts. Or if you've ever done mathematics where you have complements and you go wrap around and you see your integer wrap around, well, yes, we actually already do that. It's not a novel thing for us. When we talk about really shifting left, in my world with embedded products, or in most people's cases like wearables or IoT or their home routers type products, shifting left isn't about just adding, for example, security into your development lifecycle and your chain. When you're developing a product, you often have code in there that's not yours. So we have this concept of first party code, second party, and third party. When you control the code generally in first party, then you can shift left. But when you're working with components, and many of us actually, we really aren't really working a supply chain the right way, you're actually inheriting all of those things. So when someone says, hey, there's a vulnerability in this product, chances are it's not necessarily in your code. And so you're actually more of an integrator, less so than a developer. You're paper mashing it all together. And so it gets very hard when you're thinking like, well, why don't they just release patches? And so my world is very, very different when I think of how you shift left, because I want to go yell at, let's say, VxWorks, which is a Wind River product. I want to go yell at them less than I do the company that builds the product itself. So my world is very, very different. But I think the shifting left is the right way to go. We got to go start yelling at the upstream providers more. Like, for example, if you're downloading a Node.js package and it's complete garbage, then that's where I think security needs to go that way. Less so than maybe you, but that's another discussion we can talk about later. Now let's go to CIA if you wish.
This is why I invited Ron, because I wanted to talk about the supply chain of software, and he is the guy to talk about that. Or there's actually a whole bunch of things, but yeah. So who wants to jump in? And so I want to say hi to everyone in the chat: Ben, Benjamin, Andrea, Himanshu, Benjamin. There's like so many people. Thank you so much for coming. So who wants to say something about CIA? Because otherwise, I'll just talk I'll talk the whole time. I am very much a talker. Oh, hi, Amy. Okay, well, then I'm talking. So CIA stands for confidentiality, integrity, and availability. And so when a security person goes to a dev's team and we're upset with them, it's usually because one of those three is not protected properly. So, and this means your systems and your data. So let's say you have a system and it does a calendar. You want to make sure that the calendar is always available. Oh, actually, let's make it a planning thing, a thing that takes care of your project management and tracks that for you. So my company has one that we use for our tasks. But I don't know if you heard, Microsoft went down last week and all of Office 365 was offline. We didn't know what to do because we didn't know what our tasks were because they were all stored in there. And it not being available really affected our productivity for that 1 hour meeting where we were supposed to go through all of our projects. We had to do it the next day. And so that's availability. So that was our data and the system not being available to us. Does anyone want to give a confidentiality or integrity example? Because we're going to do the questions, but I guess we're sort of answering it at this point.
So I can jump for one. I will take integrity. In fact, it's when you're the data that you receive or are stored in the system has been modified or altered by someone, by some people, by some system and so on. And the content was modified in an unexpected way, and the data that you receive are not the same that the one that you are normally stored into the system. For example, if you store your personal information, for example, your credit card number and so on, or more your age and so on, and people will modify it to alter the integrity of the information. For me, it's the point of view that I have, but there, as always, there are not only a single point of view.
A lot of people have been commenting in the chat that the examples are really helpful. So yeah.
I'll dive in with confidentiality. Thanks. Perfect. We think alike. So I'm going to start with confidentiality from a different perspective. So most people think of confidentiality like, oh, when I go to a website, it's got the lock in the browser, right? That means it must be secure. Well, that's questionable. But when you look at things a little more holistically, it's something you want to keep secret, right? So if there's stuff, think of it like a garden hose. Encryption wraps that, it protects it in transit. Then you have data that you might not want to be viewed in the database. You would encrypt it or make sure it's hashed, and there's other sorts of things. But when I talk about confidentiality, it's not just your obvious things like your social insurance number. It's not just your passwords or where you live or your credit card data. There's different issues there. But it's also other things that indirectly affect your privacy as a human being and other things. So I'll give you an example that I don't think many people think about. When you think of your airline tickets, you think of sensitive information being your name, your address, date of birth, your credit card, your passport numbers. But there's another piece of information that you don't generally think about, which is your meal choice. And your meal choice and your preferences is actually very terrifying from a nation agency standpoint. And people don't think about it. And I love to use this as an example. Let's say, for example, I happen to follow a particular religion and I want halal food. Well, now if I'm traveling under, let's say, an Anglophone pseudo name, right, like John Smith, and I happen to be going to the Middle East, because you're choosing halal meals, it actually puts me at risk of racial and religious profiling. And agencies use that to track each other. Now you're going to laugh. All of your tickets all go through an organization based out of Montreal, and all the nations get access to it. So really, you don't have any privacy, anyways. But that's something that I think about in confidentiality as well. It's other indirect data sources that actually give people a data point about me that maybe I didn't wish you to have. So it's much more than your obvious things of my password and username and stuff like that.
Oh, that's a really good example, Ron. I agree. And I think a lot of people don't think about those things. So I live in Canada, and yes, that is the accent you're hearing. And so a lot of us will get tests at a place called Life Labs. And last year, they basically spilled tons of the results onto the internet. And like the moment they said, "Do you want to receive your lab results on the internet?" my response was, "No." And I remember talking to someone and he's like, "Well, who cares? I'm healthy." And I was like, "What if I went and I changed the results to say that you were HIV positive?" And he's like, "But I'm not." And I'm like, "But then let's say you're applying for a job." And then they can look you up and they're like, "Oh my gosh, he's going to cost us a fortune because of our healthcare plan. And so let's not hire him because he's HIV positive." And he's like, "But that's not fair." And I was like, well, obviously, that's why that's private personal information that shouldn't be on the internet. It's confidential. And he's like, "But it's not true." And I'm like, that's the thing. That's the whole thing, right? Like the confidentiality of that data, by them spilling it, that there's more risks to that data being spilled than you might realize. And I find the everyday person, they're selling off their privacy to places like Facebook, to places like every social media, let's be clear, using Gmail, all of those things. And we're like, "Oh, well, I'm not that important. I don't have anything to hide." And it's like, actually, confidentiality exists for a reason. And it's often for edge cases and for the people who are most vulnerable in our society. Do you know what I mean? Or for societies where they're not as protective of human rights. Let's call it that. Yeah. Does anyone else want to add anything? Because I'll talk all day about that. I feel like I'm getting a bit off topic. Sorry. Is that okay? Okay. So the next topic in the book, if we don't have to go through all of them, I'm kind of excited. Are there any specific topics that you want to go through? Oh, I'm frozen. Sorry about that. Can everyone still hear me though? We're all good?
Yeah.
Yeah, I can hear you.
Okay. So there was actually a question in the chat from Gary that I was thinking I would read out. Nancy, if it's okay, I'm going to put it on the screen and then I'll probably refresh myself. But basically, Gary says, so most software development is done in incremental and iterative types of cycles now. And a lot of people view security, though, as being a more absolute, like you do it one time. Are there any thoughts about combining these worlds? Like us doing iterative security?
I can try because it's in Luxembourg. In fact, it's my small Beloved country. In fact, we meet more and more projects that they are using agile methodology like sprint and stuff like that. And it's true that most of the time the security cannot be done like it's done since many years because it's not a block. When you develop a software incrementally, you have software that live across the sprint and so on. So you cannot do a final penetration test at the end because once you will do the pen test, the product will be 1, 2, 3 release later. So the thing that we have tried, because for me, I think AppSec it's an eternal try, and I have tried with some team to integrate into the team. I'm the security guys, but not as an auditor, just a buddy in terms of security, and I perform some secure code review, micro pen test. I add some stuff into the pipeline. I review the report and so on. And I try to I work with the team as a team member to do security stuff, but not only on my side, but by explaining to the team why I do this, why I do that. Does the things that I have add real value, or does it put the mess or implies that the team lose time on this point? So it's iteration, and in fact, I try to apply the same philosophy and the same mantra that the agile. It means we try, we refactor, we try, we refactor. Same things about security. So for me, it's just a try. But once again, it's just a point of view and a tentative.
We want your point of view. That's why I invited you. I agree. I also think that if you only check one time, with security, then you only get one viewpoint. Does that make sense? And you only get that snapshot in time. So if you have a penetration test, you have that one person's expert opinion of this one snapshot in time. But if you keep hiring, let's say, the exact same pen tester over and over, you're just getting their same opinion over and over, as opposed to let's look with different tools. Let's have a different person look. Let's look from a different perspective. Like if you only ever do, let's say, static code analysis, like you're just doing SAST all the time, you might miss all sorts of other things. Ooh, Benjamin in the chat has a really good comment, and then Ray, you can comment. But Benjamin says it costs 7 times more to fix security issues later in the system development lifecycle, and sometimes significant rewriting of the code is required. If it's a big logic issue, for sure. I agree 100%, Benjamin. Ray?
So I like to tell my developers that I don't do security, that they do security, right? Like I'm not in the code, I'm not fixing things. So the way I see it is security is always happening. The developers are either doing a good job or they're doing a bad job at it. Security just doesn't happen once. Like it happens all the time, and some developers may choose to ignore it and do it poorly. But that is a choice that they've made to do security poorly, right? Like they decided to cut corners or something like that, or maybe they just don't have an application security person on the team that has taught them how to do it the right way. So it's hard, but security is basically if you have a little bit of training, you're kind of doing what you were trained to do. You're still doing security when you're developing. So
it's like every time you walk into a building that's a secure building, if you decide to open the door for the person behind you, that's you making a choice to do security poorly versus saying, no, do your own badge. Like I'm not opening the door for you. Right. And every single one of those choices, or if a dev's not sure and they're like, oh, there might be a security thing I should do here. And then them saying, I'll figure it out later, or I'm not going to ask because I have a deadline, I'm busy. That's a decision that results in probably bad stuff later.
Yeah. And I would say the one thing is that I just tell them hey, you're never wasting my time because my time is there to support you as a developer. So if you're unsure, just ask, right?
Yeah.
And that is doing security. Because if I'm oh, don't worry about it, then that's something that they don't have to care about. But sometimes it is something that they need to worry about, and they just don't know that they need to worry about. So if it's just hey, it looks kind of iffy, just ask if they don't know, right? That's usually what I tell them to do.
Can I change the slight paradigm just a little bit? So if you look at 70% of the issues that you see in vulnerability reports, they're actually the result of not security per se, the result of poor engineering practices. And if you really think about that, that really changes this concept. So security is the result of a bunch of maturity things that you're doing. It's very, very different when you think about it that way. It's yes, you have a choice, but then the organization also has a choice to release terrible code or a terrible product. So it's a very, very different perspective when you start to twist things a little bit more in terms of what is security. It was you design I worked with a lot of developers over my career, and I was party in one of 4 or 5 different researching firms we just released a bunch of vulnerabilities for GE protective relays. Most of the issues that we found, guess what? They are actually the result of people not applying appropriate risk measures in their code and by designing their products securely. So what do I mean by that? This isn't about looking for things like buffer overflows. If you applied any tools and if you were a good engineer and you accounted for all the edge cases and weren't just coding because that's what the requirement said or that's what the user story said, and you thought outside the box and said, hey, how will this program degrade if it's put under these conditions? Or what will happen if it doesn't fail safely? It's a very different concept. You think of engineering, and that rigor, if you will, is not taught in school. I don't think maybe in the odd school now, there's a couple courses that introduce some secure programming practices, but it's actually, it's different. It's common sense to plan for things differently. It's like, do you know what the underlying layers are doing? So I'll give you another example. Why does my Python dictionary degrade in performance under these conditions? Well, if you knew it was an array underneath and you added one more member, it actually made a new array that was double the size and copied the old members in. You would know that you have a performance hit. Now, that's not necessarily security in the sense, but if I misuse that in a certain way, then I can affect the security of what my system is. And that's a bit of a different thing. But we think of security as, to circle back, as an absolute. But security is actually a function of time. It degrades over time. And if you always consider that, right, even if you're thinking of an SDLC thing and you look at the big end-to-end systems, right, we always test a single system alone. We never test two systems that are considered secure together. And when you put them together, then you wind up with logic errors and stuff like that. This is called good engineering, and your test cases need to reflect that. And so does your personal pride. You need to leave your baby at the door, your ego, and focus on it from a very holistic perspective, and be proud of your work. But I'm very passionate about that, so I'll back off for a second.
I feel like, so I've said this to a zillion clients, you can't do security right if you're not doing IT right. So if you have a bunch of devs that are like changing code live in prod and then not saving those changes into source control and not allowing any testing or QA to happen, it's like, yes, you have a giant crappy mess because you're not following like the system development lifecycle of your organization. So then they're like, oh, well, that wasn't very secure. How on earth am I supposed to secure a thing if you're not following any of the processes that we're all supposed to follow? Right? Like, I agree with many of the things that you said.
And also too, I mean, we always think of our processes, our SDLC, but have you ever been on a developer's laptop? They apt-get install everything. They turn off their firewall. They open everything. They import scripts on Stack Overflow. I used to run a website with a really long IP table script on purpose with a sudo rmf-r star on purpose just to teach people lessons. I got a lot of angry emails on it, and it was a great experiment. But I love doing that because people learn something very critical there. Don't run stuff that you don't understand. And I guarantee you, all of your SDK examples that you copy and paste from for, like, I don't know, Qt or for Python, they are not well designed. They don't account for sanitization of inputs and outputs, trusting and checking for nulls. I could go on and on the subject, but this is like, this is where most of my issues come from, is people not, taking 2 seconds extra and asking themselves, what does this imply or implicitly affect in my system?
If a dev wants to improve their coding immediately, I suggest every single time you go to look for how to do a thing online, like Stack Overflow or whatever, you look for the most secure way to do that thing, because whatever's the top of Stack Overflow, whatever's voted to the top is always the crappiest, most insecure, applies to every situation. There's no input validation. There's no, like, I remember when, so I've reported, because I'm annoying. And I don't work at Microsoft anymore, but I can't help but continue to report things to my colleagues. So they'll be like, oh yeah, just set this to star. I'm like, no, you cannot do that. And they're like, well, it's just an example. I'm like, no, what you're doing is creating a thing that thousands of people will copy because you're Microsoft. You're amazing. You're like one of the biggest, oldest tech companies that's ever existed. So people will trust you and copy it and paste it into God. So don't put star. And they're like, well, they should know. I'm like, no. And so I'm always like, whenever I'm like looking at their help, I like write them. I'm super annoying. Oh, Amy is saying, where do you draw the line? Because you can't read the source code of every single technology that you use. Oh, that's such a good question, Amy.
Yes. In fact, I try when I have the chance to work with developer, because I consider that I have the chance to work with developer because we exchange. And I say to them, I will try to teach you to fish and not to feed you. So I try to teach them to detect, to spot some kind of things when they copy paste thing from Stack Overflow. I do this then when I do some script, because I make vulnerability too. I'm a coder. And so I teach them to detect some kind of crappy, or say, okay, you can do it for, if you have an issue, okay, you can take the code, but feel free to ask to someone of the security department. I say security department to have a generic term. Sorry, to people that can take a look, or your tech lead, or your dev lead, or a colleague of you that are a small film with security, or a senior of your team, to take a look at the code just to say if okay, it does the job from a functional point of view, but do you have some kind of issue with in terms of security? So in fact, it's in order to every time you have a piece of code that you take to do the job, someone can take a look to verify the code, like for example using a pull request or merge request and so on. It's just one idea or tentative that I've done with dev team.
Peer review, like having another person that's your peer where you work look over your stuff before it's checked in. That's a good way to improve code quality for sure.
In fact, working with a WASP project, now that are on GitHub, it applies the same thing, because on projects that on which I contribute, there are a notion of pull requests of someone review your contribution, code, or documentation, and check if you miss something. And for me, I say to dev team to use if they can apply some kind of merge request, pull request to have another point of view and mimic GitHub. In fact, mimic open source project philosophy when they can.
I like that, and I think it's wise. Does anyone else want to comment? Well, it got really quiet. Oh, it's because you muted yourself.
On Amy's question, I really like that, because if you're working in a very large system of systems, like embedded isn't as bad because we generally have a very limited amount of libraries that we use besides the core operating systems. When you start going and saying like, hey, I want to go add a web stack, you automatically like went tenfold your dependencies, and I guarantee you have no idea what 3/4 of the code is doing, and you're probably using less than 1% of it probably, right? If you look at jQuery, what are you really using out of that whole library? So there's a bunch of issues there on that. But what I try to tell people to do is to think of your whole application. So whether you use containers or other compensating controls like a CH root, like a jail, or for example, if you're in C, you're going to use the Linux cap capabilities, where you basically say, like, how many of you have all of your programs probably run as root or a service user, and you've not actually downgraded your permissions to nobody? That's what you should do by de facto once you've set everything up. So you have all these kind of things to kind of limit and give yourself a chance to be able to deal with an issue if it occurs later. So you try to wrap and control your risk into manageable chunks. So what we call it in the industrial world is, and by my friend Andy Bachman from Idaho National Labs, you engineer out the risk based on the consequence. So if your consequence is, I don't want to get my box popped, and this is a very critical application or a very critical worker in the whole system of things, then you wrap all that stuff. You try to contain all of the code. So for example, if you use a library like libsharp compress or some of those similar ones, you'll notice that it's all about context too. So how am I using that library? If it's not really only taking inputs and it's only being used to compress, let's say, the diagnostic output and send it outwards, I'm not too concerned about potential vulnerabilities going into it necessarily, because it's all about context. And so if you engineer and wrap and you say like, hey, this thing should only open one file here and under those permissions, and it can only be so big under those conditions, you engineer yourself into a safer position. And at least if you have lots of telemetry, logging and stuff like that, you can at least get an idea when things are starting to go wrong before they do go wrong, and you're helping yourself, especially when you have creative users that are starting to toy with it, because if your power users are toying with it, that means someone else is going to toy with it later, and it's going to be way worse.
There's actually a bunch of really awesome questions in the chat. So there's been a great conversation going with Gary, Benjamin, and Ben. And so Benjamin was saying, what do you do to improve security in builds in the CI/CD pipeline? So this is definitely a topic we're going to talk about later, I believe, in chapter 6. And then we're also going to talk about it again in chapter 8, which are weeks from now. But I would say that adding security tests in a CI/CD pipeline sounds like a huge win, as long as there's high accuracy and high speed. So for instance, running a SAST scan, so static application security testing, that takes forever and there's so many false positives. But if you just run a scan for secrets, it's really easy to spot if someone's checked in a secret because it's usually this long and it's super random. There's lots of entropy on it. It's like, yeah, no one names a variable 200 characters that are random, right? So that's a really fast and highly accurate check. And so that's often a good one for a pipeline. Does anyone want to weigh in on CICD, even though it's wildly off topic? Because I love this topic.
I want to say protect it. Protect it. Protect your CI/CD so you don't wind up. I mean, there's many things wrong with SolarWinds, but one of the things that they did do wrong was protect their CI/CD and all of the things that fed into it. So I will throw that out right now and say, don't take this for granted, especially your signing authority that signs your code or your packages.
The things that I have started to do with Dev Team, it's as I also perform some kind of penetration testing against mobile and web application. In fact, I reverse the techniques. When I want to say it's the techniques that I use to reverse mobile application. In fact, I provide to the team a script, Python and so on, that try to automate the things that I do when I reverse. So in order to say, for example, when you release your APK or IPA, you run this kind of script or so on to, for example, try if you have secret, if you have, for example, server name otherwise than production. In fact, as Tanya said, small checks, very quick, but that performs the same kind of checks that will be done by a pen tester, for example. But limiting only things that can be automated. For example, searching for secret. In fact, searching to stuff not related to the production one and remaining artifact that has been left and for testing and so on. And same thing for web application. For example, for web application, the things that I propose and I provide, it's a script using a double buffers or discovery and so on, just to using a dictionary of a file from which the application should not be present after deployment, and run this kind of tools just to ensure that, for example, a list of files is not present after the deployment. Same thing for header, same thing for and so on. It's just a matter of script. In fact, in my point of view, when you work with development team as a dev guy with a security guy or security buddy, you must produce something. You must provide pragmatic stuff, script, pipeline. In fact, even if there will be just a foundation that will be improved, but you provide some kind of effective stuff that enhances the CI pipeline. And organic, I just want to answer to a question of Benjamin. And after I cut my this code can be hundreds of thousand lines. So why you can check or you cannot check always all the code? It's very, very right. You're absolutely right. The things that I've tried is the same idea. In fact, I try to provide some kind of pattern. For example, custom pattern, or I try to custom rule for the SAST, or just a custom script. Sometimes it's a custom script to search some pattern to say, okay, you cannot check the code, but we know, for example, in Java, if you have some kind of pattern to send a request according to the technology, the code smells not good. For example, if you have a trust all SSL or so, the code is not good. So in fact, I provide some kind of just script to spot major flow, but to be honest, I will miss for sure some things, but just some pragmatic stuff to detect the more common things in order to prevent someone to do manual review. Okay, sorry for the time.
No, it's good. I invited you because I wanted to know these things.
I mean, there's a lot of good tips that you can talk about for securing like CI/CD pipelines. The one thing that often I think gets missed is separating the build and the deploy on two different systems. I mean, like if you have it on one system, like that code that gets when it's during build time has a lot of access to pretty much everything. So separating that stuff out is going to greatly increase like how much security. But I mean, like there's so many things you can do. I mean, like you said, there's going to be a whole episode on on just that one topic.
It is one of my faves.
We're also talking about a few things. So we're talking about securing. Even one way to improve your timing on your security test cases is only test the interfaces. So one of the questions was like, okay, where do we draw the line? Well, one of your lines might be in almost, your everyday daily test cases, or every time you run a major build, right? Not an iterative build, but a candidate build. You do all these things that test interfaces. So I saw Ben was chuckling about Ripple 20 and Urgent 11 and that type of stuff. I laugh at this stuff because this is 1990s problems. And they would have been found if you would have done interface testing with buzzing and applied destructive testing. Actually, the reason why those exist is because the vendors didn't buy the support packages, and that those patches never made it in the mainline code, and no one ever tested for them. But I can't really say more about that, but you can go do your own research on that. But what I like to do, and this is an issue sometimes with JSON type interfaces, is that there's no descriptive data models. Data models, yes, they're a pain, and you have to do all this going through it. But if you validate your stuff, like XML with XSDs, that stuff helps you so much because it defines how your program should work, and it limits the amount of testing time and all of those extra checks that you're doing. You know what good should look like. You know that value should be between 1 and 100 bytes, and that, but whatever it is, like, you can do these things to help yourself. And yes, it's a bit of time up front, but if you write very flexible programs that are like interface or configuration driven, the amount of code that you'll actually write at the end of the day is 10 times smaller on average than if you just made this monolithic function with a ton of if statements that just looked at data as if it was voids, if you're a C programmer. So if you really think about things in a more secure pattern way, not an anti-pattern way, you'll find out that, as I said, engineering will save you, and you'll get security as a side effect. And it's a very different strategy. So there's some really cool stuff going on here, and I see that Himanshu was mentioning quality of code is more secure to be true, but that case devs should be trained to do more secure coding. Well, they should be learning how to code properly in the first place. But we can go down those tangents all day long on whose responsibility it is.
I feel anyone that's teaching coding, that it's part of their responsibility to teach how to code securely, but I'm really biased because I work in AppSec and I never learned any of that. Also, I've noticed I'm frozen, but that's fine. I was wondering if we wanted to talk about one or two of the other topics in the chapter before going to the questions, or because I kind of wanted to talk about factors of authentication, because basically from my point of view, that is not covered, or that the general populace doesn't understand. I find that, so a lot of, for instance, okay, so the Canadian Revenue Agency, so it's like the IRS for the United States. And basically, like when you log in, they ask for a username and password. Then they ask for a secret special code that they've mailed to you. And then they ask for a security question. And all of those are the same factor. It's a thing you know. Does anyone want to volunteer to talk about what the factors of authentication are? Ray, you know you want to talk.
Yeah, I guess I will. Let's see. So I guess the first one that you just mentioned, right? Like something you know. That's like a password or a passphrase or basically any kind of memorized secret, I think is what NIST calls it. Then you, or I guess that would be, I guess, non-memorized secrets too. Any kind of, like, it's something that's stored in like a password manager or something like that, right? Something you have is another one, like token. I guess your phone could have like push notifications or SMS if that's something. And then something you are, so that's your biometrics stuff, like thumbprints, like fingerprints, facial recognition, stuff like that, maybe voice recognition. But then, like, also there are a couple other ones, like where you are. So geolocation, geofencing is a thing. Like if you're on a network, you're already assumed more privileged on that network than if you're off the network. And there's also like behavioral ones, like something you do, right? in tech, it's I guess like the example that I can think of is like where you're like on touch screens, you can like draw like a happy face and it would unlock your computer or something like that, right? I guess it's in other things it might be like a secret handshake in real life or something like that, right? So I guess there's 5. Usually like no one really thinks about the something you do or something or where you are, and like those ones are kind of weird, I would say, just because like we don't really think about them, but they're there and they're just as important, and they're just as good or as bad as all the other 3 that we tend to talk about more.
Yes. Yes. Andrea said it. It's something that you have, something you are, something you know. Well, why do we have different factors? Like, why bother?
That's what I say. Why bother?
No.
Well, I mean, generally having one factor, if that gets compromised, hopefully it's less likely that a second factor would also get compromised, right?
Yeah, it makes
So
it.
defense in depth kind of idea.
Mm-hmm. Compensating
Have you
layers,
seen this?
always.
Yes. Have you seen the statistics on, when someone does a credential stuffing attack? So, credential stuffing attack is where someone takes a whole bunch of usernames and password combinations. So, that's called credentials. And then they just try it against a website with a script. They try all of them really quickly. And lots of them will work because people reuse the same password on many sites, which is bad. But when they do that, whoever has multi-factor turned on or 2-factor authentication turned on, they'll never have that other factor. To get someone else's other factor, you have to work really hard. Like if you want to get my password and let's say I reused passwords, which I don't because I'm a security professional and I'm obsessive, but let's say I did that. Years ago when I was a dev, I did because I didn't understand. And also I knew I could never remember all of them. But if I had a second factor, unless you stole my phone, or in my case, like I have an authenticator app, so then you would need my fingerprint too and my phone. And so that's a thing that I am, my fingerprint, and a thing that I have, my phone, plus you would have already had to steal my password. It makes it very complex for an attacker to try to get it. So basically anyone with this 2FA turned on, generally in a credential stuffing attack, you're safe. Do the rest of you sort of agree? You're allowed to be like, I don't agree, Tanya.
We're talking about it in the sense of user-based inputs for things, right? We're not talking about non-human things talking to each other. And there's another piece that we should talk about. How do we do factored authentication or mutual authentication between flows, right? So if you have multiple containers, do you trust the IPC across between the 2 of them? So I look at things a bit more differently in terms of how do we deal with that. Recently, I went after an IoT device at SANS, and we were discussing how I could hawk their credentials. And they were trying to do some Tom trickery, and then they actually put the certificates of the private keys inside of the statically compiled binary. So they were trying to do some stuff. They were saying, well, no one else should be able to get to it, and my embedded device doesn't have default keys, and it will talk to this one. There's much more there, and side channel and out-of-band attacks are something you need to consider when you're not thinking about user-based applications. So let's say everything is based on phones. And yes, 1 in 10 million people have the same fingerprint as me. Yes, that's actually the statistic of it. You need to consider some of those things, but also you need to consider what are the other ways that someone could get into my platform. So you've probably seen people go after TPMs, where you store your credentials on your computer on more business-based laptops. Well, or for example, you're using OpenSSL, but you have all the secure coding done. Well, actually, if you're dynamically linking to an OpenSSL library, I'm actually just going to put one in there with debug symbols and go print out your key. So you do need to keep in mind that depending on how you apply your factors and what you're trying to secure against with your compensating controls is all part of these very interesting aspects for security, depending on where you are.
Do we want to talk a little bit about defense in depth and why we do that? Because whenever I am talking to a client, they'll say, oh, well, we already have one defense. You don't need to be obsessive and have two. And then I try to explain the value of having multiple layers and how sometimes, people don't go through that layer. Sometimes there's an insider threat. Sometimes there's an insider mistake. Sometimes that doesn't work, right? Does anyone want to venture into the why we defense in depth, like multiple layers of security, not just one, is potentially a good idea?
I can try. I have a story in mind. A few months ago, we do an assessment for a client. We do some injection. We say, okay, why? There seems to have input validation. Sometimes happen. And we do the report, and the client say, no, your report is not right. Why? Because in fact we have missed to enable the web application firewall. So in fact, if we had enabled the web application firewall, you cannot do the injection. So in fact, your finding is not true. Okay. So in fact, for me, the defense index is like an onion. In fact, it just each layer that you had will make more difficult to breach the final target. For example, your applications. For example, a WAF, web application firewall, is a good point. In addition to the secure applications, in fact, because it will block most of the injection, do some protection. It forced you to find bypass, so you had to spend more time. But at the end, even if you bypass the WAF, you must deal with the security of the application. So for me, the defense in depth, it's I see it like an onion. It's made you add different layer as much as you can, if you want, depending of the risk, the technology, the budget, different factors depending on your application and culture and technology and so on. But each layer that you can add will add you another defense and a wall that an attacker must break to reach the center.
Someone in the chat is mentioning peppering. And later in the book, so not in this chapter, we talk about how to store your password. And so when you can hash a password, which means you run a cryptography method against it, like a mathematical equation, so that you can never get that value back. And then you compare when someone enters their password against. So you do the mathematical equation again, and you compare both the hashes, and if they're the same, you let them in. But in the book, we talk about multiple layers, so you should add a salt. So a salt is a long random number or letters, just random characters that you add on the front, and then you hash it. So even if someone spills a whole bunch of passwords, what someone could do is if they manage to get a hold of your hashing algorithm, they could run common passwords through and then try to match things out and guess what passwords were. But if they don't also have the salt, it would be harder. And I was explaining that I learned about peppering from you, Dominic. I don't know if you want to talk about that, but it's like an extra layer of protection.
I can. I must rent the honor to Ellie because it's Ellie and Ellie that teach me this the paper. So I will to explain. When you store for example, you add the salt to your password. So most of the time you store the salt. The salt is unique to a password, and most of the time you store it with the password. It's not a secret. In fact, you can store alongside the password into the DB. But for example, if someone an attacker achieve to, for example, extract the DB contents, so he will have the hash, the salt, and he can start an offline brute forces using tool like Hashcat, for example, depending on your algorithm, to recover the plain text of the password. So it will not break the password because it's hashed, so it's one way, but it will try to recover normally the value that once he applies the same computing that you will reach to the same hash. So with this way, it protect you from the fact that if you and me have SheHacksPurple as a password, it will be different into the database. So it's one point. Okay. But The issue is if an attacker bring back the DB outside, for example, a screen injection, it's perhaps game over for us, depending on the strength of the password. So the paper is adding another piece to the algorithm. But this information, most of the time, it's common to all passwords, and it's stored into the configuration of the applications. And sometimes, unfortunately, are coded into the code, but we will say in the configuration. So when you will compute the password, you will concatenate, for example, the paper, that is a string or a chain of bytes, but really random and not easy to guess. You will add the paper, the salt, and the password. You will hash it, and after you have a result. So if, as an attacker, I steal the database, okay, I have the salt, I have the result of the hash, but it misses one information. It misses me one information to be able to perform this brute force attack, because it misses this paper. And but it's if the paper cannot be guessed because it's a full random value, I cannot, in theory, cannot do this kind of attack. But the main issue is, if you have this kind of information, you must be aware that you must store the value in each instances of your application. So if you have, for example, a multi-instance application, you must synchronize your paper, and once you want to change it, you must set up a migration phase in order to support the old paper and the new paper. But so it's not a perfect way. You have pro and cons. But the objective is to prevent you that if someone steals the database or the storage or the location where your password are stored, and alongside the salt, you have all the information. So I hope to have resume the paper.
It's great. I'm noticing I'm frozen again, but I don't care. Do we want to start going through some of the questions? Because we're an hour in, and I want to make sure we get through all the questions. Is that okay if we start the questions at the back of the chapter 1? Okay, so the first question, it's awesome because everyone's going to disagree with me, and that's what I want. It's not a good discussion if we all just agree with each other for everything. I want to see different viewpoints. This is why I invited a bunch of people that I think are very, very, very smart, who have different experiences than I do, so we could all talk about it and get the best answers. So the first question that we had in the book was, Bob sets the Wi-Fi setting on his pacemaker to not broadcast the name of his Wi-Fi. What is this defensive strategy called? And I said, it's security through obscurity. And in the little answer key at the back of the book, which I've already told you I know is lame. But basically, if he's not broadcasting the name of his Wi-Fi, it's less obvious for them to attack. But Ron had a really interesting take on this that I liked. Ron, do you want to share?
Sure. So I actually, I didn't even know there was an answer key at the back of the book. This shows how much I read the tail end of books. So I called it jokingly security by obscurity, but it's actually the principle of least functionality. It's not just about, hiding that it's my pacemaker or whatever, but it's the reduction of an attack surface. So I called it, it would be otherwise known as, you would say, hardening a device, and it would prevent the disclosure of information, because sometimes even your ISP home router says it's a SHA cable, whatever. That tells me it's a SHA router, which means I know what vendor it is. Oh, guess what? What Wi-Fi stack is it using? So you can actually do a lot of inferences there. But really, what this is about is you're trying to reduce the potentiality of someone trying to use that as an attack vector by a malicious party, or even accidental interference by others. So when I say that is, if you're saying there's a Wi-Fi hotspot and maybe it's wide open or whatever, you're actually stopping people from going onto it. Let's say your pacemaker didn't have an encryption authentication mechanism set up because Joe Blow surgeon didn't set it up properly, or the technician. Well, what happens if that device will hang or have issues if a second or a third person connects to it simultaneously? And so you're trying to prevent yourself from accidental oopses, as I like to call them. So it is a very defensive strategy, but it's very I like to compare things like driving in Canada in the snow. So there's a likelihood of me winding up in a snowbank at some point in my life. And so I have a number of options. And some of those might say, well, let's have an all-wheel drive car. That will surely stop me. No, it will help under some circumstances. So I have a choice here to keep my car parked, choose to drive only on cleared routes, right, that are salted like bus routes. And I have a choice to have all-wheel drive, winter snow tires, have blankets and stuff in my car. And those are all things to try and prevent me from going into a snowbank. And I get to make the choice of trying to do it. The reality is I still need to drive from point A to point B. And just like as I would have to have a pacemaker, but it's reducing the likelihood of an oops. And just, just as you would defensively drive, you should do the same for your devices.
I like it. I like it. Does anyone else have comments on this? Because I just kind of agree. I remember when I first joined a security team, we were trying to interview consultants to come in and help us with a big project. And one of the questions was security by obscurity or security by being open. And I remember thinking like, what the hell does that mean? And what they meant was, should we do open source or proprietary with our source code? And I was like, always you would do closed source code unless you're making a statement for open source from a security perspective, and they're like, well, someone could reverse engineer it. I'm like, but then it's expensive. And then it's more time. And they're like, but what if your code's just open on the internet? Then all these magical fairies on the internet that are security experts who just love reviewing code for free apparently are going to come along, work for free to review your code and then send you really nice bug reports on it. Any thoughts on that? About like security by obscurity, like having your code closed source or open source, like available on the internet, like GitHub or something?
For me or for one of the other gentlemen on the call?
Oh, everyone. I feel like the smiles that Dominique's attempting to hide and Ray's just like full out. Do we think that there are magical humans that just run around, that are security experts that run around on the internet reviewing all of the open source code on GitHub and then just sharing the results to those projects? No, I didn't think that either. It's weird though, because a lot of people seem to think that. I would love for those people to self-identify one day because I have some code I need them to review for free.
If your project, like let's say the Linux kernel, which by the way, Linus and his very Gandalf-y type power saying like thou shall not pass. That one's probably a better example of how multiple eyes on might be a bit better than some other projects. But if you're writing an obscure serial driver, no one cares about your code anyways. So you just gave basically someone a way into the kernel. But when we talk about like the overall ecosystem, people do a, pardon my French, piss poor job of securing their source code bases and dealing with the inputs. And also there's another piece that's a really hidden thing here. Everyone assumes the vulnerability reporting process system, MITRE, and all of those agencies like CDI and working with CICA, which I do work with, and they sometimes do great work. And then I have vendors that are a humongous pain in my rear end on the other side of it. And so there's actually a lot of politics in the disclosure of vulnerabilities, even if I did report it, and making sure that it goes backwards into the code, and probably it will never, unless I really push on them to do it. So it is a really complicated process, and the whole vulnerability disclosure system is an honorary system. And that is something everyone really needs to understand. Yeah.
It would appear that people in the chat really, really agree with us, except Benjamin, who just wants to review all of the code for us. So thanks, Benjamin. I do. So Amy's saying she's a web dev and all of her stuff is open source. And Benjamin's saying, I do that for third-party code for security review before a product goes live, so we know what the security risks are of each dependency. Well, that's brilliant, Benjamin. That's really awesome. He's also suggesting Sneak as a potential thing that you can use to review the third-party code. And yeah, definitely using some sort of software composition analysis tool is good. I just wanted to share what some of the comments are, because I feel like the people in the comments are having an awesome conversation too. And people who are audio only might not be able to hear it later, right? So I love all your answers. Do we want to go on to the next question? Do we feel like we're ready for that?
Sure.
Okay, well, I'm bringing us to the next question. Dun, dun, dun. And so name an example of a value that could, so in the book, we talk about hard coding and how you just generally should not do that. So I was explaining to someone that's not technical last night this question. So I worked at a startup throughout college, developing software for them. Surprise, surprise. And we hired a co-op student from my program who was 2 thumbs down. And anyway, so when she left, my boss was like, could you fix this bug in her app? And I was like, sure. And yes, I was working at the only startup of all time where we had 2 lady coders and 2 dude coders. So it was actually gender parity at our very small company. But so I was like, hey, look at this. And so we put, 5, and then it was a bill of materials. And we put 5 in the other thing. And then I press the equal button. It says 10. And he's like, yeah. I'm like, watch this. So then I put 50,000 in the first one. And I put 100 in the second one. And I press the plus button and it says 10. And she had hard coded every value in the entire thing to the examples that he had said to her, not understanding that there were several calculations that needed to happen behind the scenes. And that is what hard coding means, is coding the answer or coding exactly what you want it to do instead of having logic to make that decision throughout your code. But sometimes you kind of do need to hard code things, as my embedded systems friends tell me. Does anyone want to give an example of what could be hard coded?
Yeah, I guess I can.
Okay.
I mean, just based off of anything could be hard coded, right? No.
No, but ideally.
Yeah. No, I was just joking. So constants, mathematical formulas are good examples of, like, pi, the speed of light, things like that, things that don't change. Even then, you probably, if you could put them in a configuration file, it kind of makes sense to do so. But things that will never change, that are not super sensitive, are good examples to be hard coded, I guess. I mean, everything really, it really just matters in context more than anything else. Does that make sense?
Yeah, it sure does. It sure does. So let's say, for example, let's say you're using a Raspberry Pi, okay? And you want to hard code in which GPIO pin that you want to turn on an LED or look for a button press. You should put that in a configuration file, but I understand that you don't. And if you're dealing with a microcontroller and a board that's never going to change, right? The pin is always going to be, let's say, I don't know, IRQ 11. Well, so what? So be it. Put it in. Or where the registers are for that microcontroller to do something during the boot cycle or something like that. Those are things. Or if you're on a shared memory bus and it's hard coded in and you're sharing it with the driver. So those are things where you'll see that, and that's okay. Another place that you will see hard-coded magic bytes, if we'll call them that, sometimes will be in the preamble of a file, or there'll be multiple headers and they all have identifying bytes. So one that you might know is a Microsoft EXE or a PE binary, and that's multiple layers deep, and you'll find out what it is. Or an MSI is actually an OLE file, and that has magic bytes. You can actually, there's multiple layers of magic bytes, and that tells the operating system how to interpret it. So if you're running a Linux ELF file, right, your typical compiled binary, it says it's an ELF at the front. If you're talking about a bash file, you also know that with the pound sign, right? The file system knows how to interpret it. So sometimes hard coding is okay, but then it's also not okay because people look for things like an extension on a file, right, like a .png, but it's actually not a .png because someone decided to go look for a MIME type. So, and that's garbage. It's very stinky. And so there's all sorts of stuff there that you can do to manipulate programs and for hard-coded values. And another area people always forget, right? They're looking for secrets and stuff like that. And strings are okay to hard code to a certain extent. But one thing that everyone forgets is in initialization vectors. They always hard code them to zeros, which means that you basically destroyed all of the strength of whatever hashing algorithm or something like that you're doing. The incorrect way in British English would be like a nunce. It's actually an n once. Don't hard code those things. So there really depends. Embedded is okay to do defines, and it's fine, but elsewhere, not so much.
I think Tanya
Second.
froze again.
Oh, I'm back. I'm back. Am I back? I'm really sorry. I'm kind of a stepmom now, and I had to do a kid thing, and so then I'm not at my normal place, and I apologize for my not fantastic internet connection. Can everyone hear me though?
Yes.
Yes.
So you,
I think you should set up NAC on your network.
I was just going to make a joke that I look great in black because there's just this square of black instead of me. But, I like that. And I feel like most of the time hard coding is the wrong decision, I guess is what we want to have people take away with this. And that if you're doing it, there needs to be a decent reason. Do we agree on that perhaps? As
Yeah.
a thing?
Yes.
I have another.
I think that's fair.
Yeah. Okay, so I have more questions. So in the book, we talked about usable security. If you make security totally unusable, people will find a way around it. Trust me, I was a dev. What I would call a workaround, they would call hacking or insider threat. And so I remember someone telling me they worked at a hospital and all the nurses had to drag these carts around and all of them had this plastic styrofoam cup on top of a thing. And she's like, what's that? And they said, oh yeah, they added this security thing where we had to be so close or they lock us out of our system. And the first day we had to be locked out of the system like 500 times. Like I could not complete my job because of course I'm always away from the system more than 60 seconds, but I'm still in the same room, right? And it's still safe. So they all put these styrofoam cups on the thing the next day, and then it was unlocked indefinitely. Like overnight, with other shifts. And yeah, one person was just logged in indefinitely on each machine, which is obviously the antithesis of what the security person wanted. So if we make security so it's not usable, we won't get what we want, which is less risk, less bad stuff happening, more everyone just getting their jobs done safely. So a captcha, does anyone want to define captcha and like say why it is or is not usable security? Okay, I'm going to define captcha. So captcha, a captcha is an image that a software system will put on a screen of like a bunch of letters and numbers or characters, and it will ask you to type it in so that it can prove that you're not a bot, that you're not some automated system. They're trying to prove that you're a person. But unfortunately, I don't know about you, but like I do captchas all the time and fail. So Google has one called reCAPTCHA, and it'll say, point out all the, select all the boxes that have a crosswalk. I fail the human test at least a few times a week. And I find it super frustrating. And I would vote that it's not usable security because it's so frustrating and it's so annoying and it slows me down trying to get my work done. What does everyone else feel about this? Do we feel it's usable security, not usable security?
I think it depends on the implementation. Sometimes the reCAPTCHA is like you click the button and it just says you're a human, it knows you're a human, and you don't have to click anything else. G-test is another one that I find more usable, but then like the ones where it's just like, is this an H or a B because there's like 20 other different lines running through it? I can't tell. Like those are super not usable.
Anyone else?
Yeah, so I'll expose a little secret about myself. So I had an answer on it. I said depending on who you were, it's usable. And because yes, it can be irritating, but it might be actually too abstract for many persons. So if you're the revenue agency for Canada, having a captcha isn't very good if you're dealing with an audience that struggles with technology in general. My sister has Down syndrome, and so if I asked her to be fair, and she does a great job navigating technology, don't get me wrong, she can use Amazon and go on IMDb and go on YouTube. But I know for a fact that for her, if you said, what is this? Or how many school buses do you see in this picture? She would not get it. And I would probably say the same to my parents. They would be like, I don't get this. Like, there's a school bus. They might click one of the pictures and they eventually might get, brute force their way through it after several failed attempts. But they will struggle with this. Now compound that with those ugly ones with the characters and different with extra noise being added and all of that extra type of captchas, or even adding 2+2. For my sister, that is an abstract human concept that she doesn't understand, because for her, like if you said, okay, how many deer do you have outside and there's 2 deer, she could tell you there's 2. But when you give her a rote learned cue like on the screen, she wouldn't understand how to add 2+2. So it's really contextual. And it's in the eye of the beholder. And then if you compound that with like bad eyesight and not knowing how to use technology, then your effectiveness of your security control on the triangle of convenience to time to cost, or all those type of triangles, you just wasted your time. Now the good news is with the reCAPTCHAs that were looking at text back in the day actually improved Google's machine learning for free on how to translate books. Not too many people know about that. It was a side effect of it, but it can be very frustrating. But it is a tool.
Yeah. It's because of evil bots. If we could just get rid of them, it would be so nice. I think that users kind of hate them, but we don't really have a great alternative right now that exists that's better, because probably everyone would do it. I am going to put us back to the 4-way all of us view and go to the next question. So can anyone give an example of what a good implementation of usable security could be, where it's like, oh, that's nice, that's good? I can start with an example. So the example I give in the book is, so there's this Canadian company called 1Password, and they want you to store your authenticator codes in it so that it's encrypted within your machine. And I really like that. But what they do is, so when you go to log in somewhere, you press a button and it will automatically put in your username and password. And then it copies your one-time code to your clipboard. And then when you press log in and then it asks for the clipboard, you just click paste. And often it just pastes it in for you. And I was like, oh, that's so cool. And then you log in and then it removes it from the clipboard and puts back what was previously on the clipboard so you don't lose your work. And I'm like, oh my gosh. Yes, this is making security easier for me. And when I was showing it to a bunch of my staff who are like from the marketing viewpoint or sales or administrative viewpoint, they're like, oh, that's really cool. That's way less difficult. Because I was like, press Control V. And they're like, why? I'm like, because it's in your clipboard. And they're like, but I didn't do anything. I'm like, don't worry, it did it for you. And they're just like, oh, that's less scary. I can use MFA. I thought it was really hard. And I was like, no, they're making a difficult to use sometimes security control way less difficult to use. And so that would be my example. Does anyone else have an example they want to share?
In fact, the one I don't know if I can say a very good usable security, but I like the approach. In fact, on Amazon, when you enable the MFA with your phone, in fact, when you log in, it sends you an SMS, but not with a number, with a link. You open the link and you have a menu to say approve or deny the transaction, the login transaction. So you can, I like the approach because in fact you go on a site that give you some context about the browser, about the browser UI and so on. I really like the approach, in fact, but I don't know if I can say that is usable because as I'm working IT, for me usable it's like I'm not very honest, but for me I like the approach.
Cool.
I have a nice one and something we all have. So I'll show you an example. So on my phone, I have a fingerprint reader that is ergonomically exactly where my finger needs to be. And so once the password goes into there, I don't even have to think about it. Like what is my banking credentials? I don't even know. There's no 1Password, no credential vault. Well, there is inside the phone, but I don't see it and I don't know about it. And so for people like, let's say my parents, and I hope that they're not listening, but they struggle with this, and that sometimes I have to help them set up their fingerprints, and your fingerprints do change over time, and yada yada. But that is a very good example to me where I seamlessly don't even have to enter a PIN into my phone. Yes, I do have backup methods automatically because Google forces me to do so, but that fingerprint thing into a unified vault, yes, okay, there's flaws, but it's much better than not having it, and so it's very handy for people that don't understand what a password is.
Yes, I love it. I love it. Oh, those are great examples.
I thought of two actually.
Okay.
When you sign on to into a Google account or your Gmail account on a new device, a new browser or something like that, Google sends you like a push request and an email, and it's like, is this you? You can like absolutely choose to ignore it if you want, but if you choose to be like, yes, this is me, or no, this is not me, like they will take action depending on it. I find that usable because I like the fact that I can ignore it if I know it's me, and I'm like, I'll deal with that later. The other thing is the strict transport security header that just like as a user, you don't even need to know it exists, right? And it just, you automatically like if the person did it right on the website, like you just are over HTTPS and it stores that setting in your browser. I mean, like, to get that working, there's a lot of technology that happens, but to a user, it's seamless, right?
Yeah.
Like, there's no interaction.
Oh, I want to give an example that's very similar to yours, the anti-CSRF token. So previously, cross-site request forgery was an issue, and we talk about that in Chapter 5. But one of the best things that I've seen our industry do in a while is they built into the framework of .NET and some of the other modern frameworks where it will pass an anti-CSRF token for you. So it protects your session from that type of attack, but the user does nothing. They have no idea this is happening, and they just have this extra layer of protection protecting them. And I really like how the industry pushed all the way left, right at the beginning. You can't, I remember doing a pen test and saying, you don't have to pass this because .NET's passing it for you. Also, you passed it in the clear. So stop doing that. But, and it was good. And it's nice to see our industry trying to accommodate users, because when we make security really difficult, we end up with those nurses with the styrofoam cup, and they're like, listen, I'm a nurse. I save lives. I have crap to do. I do not have time for you to get in my way because I'm going to save lives. And I like that the industry is thinking about people more, or I think they're trying, or us. Okay, I have another question, because do you feel a bit like this is like a college lecture where you're like, oh man, the professor's asking her questions. She's the worst. Okay, so the question is, when using information from the URL parameters, so up in your browser, for anyone that is into dev or is into security person, there's the URL address, right? But sometimes at the end, there'll be a question mark and it'll say, ID equals 1, 2, 3, 4, 5. That's what we mean by a URL parameter, that value there. Do you need to validate that data? And if so, why? And if not, why not? And this goes back to the section of the book, Never Trust, Always Verify. So you might get my extremely biased viewpoint on this, but does anyone want to take a crack at this?
I will try, but once I want to add just a caution. When you use parameter in the URL, yes, you must already validate it, because never trust the user, never trust anyone, anything. Be paranoid. In fact, when you use a URL, things that I see that is over forgotten, it's when you use parameter into URL, keep in mind that in the server until we reach or in the user story, the parameter, the query URL, all the parameter on the URL will be stored into the browser history and into the access log of the final server. So only use parameter in the URL for not sensitive data. That data, for example, preference and so on, UI preference. But do not use them for sensitive data, because you take the risk that data will be stored into the user history and to the access log. But to come back to the original questions, yes, you must always validate it, whatever the parameter, whatever the information coming from URL parameter, phone parameter, cookie header, and so on, always validate. Because in fact, if you achieve the point when you validate all the incoming information and the attacker cannot influence your program by external by providing external informations, your attack surfaces will be reduced. So it's all for me.
Oh, I agree. I mean, it's really obvious that I agree. Does anyone else want to say anything on this topic?
I laughed at the fact that that's a question. So you said why or why not, and I said always, because to me there is no why not. I feel like Yoda. There's no why not. Because you need to validate everything, and validate means different things though. So looking for the presence of a variable does not mean that it's a good variable, right? So user equals, well, user equals could also be anything else, right? Like just looking to see if it's null or not, right? That might be one person's definition of validate, but it is not validating and verification. Does this look okay? Is it empty? Is it too long? Is this an acceptable input under certain circumstances? So think of state machines. For example, there's an issue, I worked on an issue where we were dealing with an airline and the ordering of tickets. And so just because I had an authenticated session, I could actually manipulate someone else's flight records because I had an authenticated session. So I would just change out the PNR and I could delete other people's tickets or reorder for myself.
Oh my God.
Because I had an authenticated session. I have a legit account, but I shouldn't be able to tamper with someone else's. So this is why you do those things when you think of state machines. For example, you should never be able to issue a delete without a successful login, and so there's a state machine in there that you need to physically track. I know I'm very computer science orientated. That's why you sometimes, we can go down a tangent on whether or not the academic system is okay or not, but it does give you a vocabulary to think of these things, which is probably the biggest thing I ever got out of university. But you can add those other pieces there on just looking for beyond the URL parameters. And Dom made a great point, what shows up in logs, or actually there's another thing, there's no such thing as perfect forward security when you're dealing with Amazon. There's something that no one thinks about. You're often in conflict with TLS rules for PCI because they terminate your SSL connection as well. So even if you're tunneling stuff, everyone says tunneling is great, let's put it all through. That solves one threat issue when you're dealing with confidentiality. It doesn't handle some of the other pieces, and so you still need to validate even if you shove it in a TLS tunnel. We can go down all this sorts of stuff, but generally your encrypted connections do get terminated regularly, and then everything in reverse, the response goes back through into that tunnel, and then you weren't the wiser. The other thing is to not validate on the user's client interface too. Like, don't ever trust this, right? It's a good keep people honest tool, but it's not the tool.
Yes. Also, I feel like it's an input to your program. And sometimes devs will think it's not an input. Well, I put that value there. So it's not an input because I put it there. But the reason why it's an input is because it could have been changed by the user. It could have been changed potentially in transit, depending upon how the transit goes. And if it can be changed, if there's every single input to your app, it doesn't matter if it's coming from your database, your own database, if it's coming from an API, even if it's your own API, validate that input. And if it's not what you're expecting, say, no, thank you. Come back when you know how to talk to me, right? And if every single dev everywhere validated every single input, I think that we could all just go home and just become devs again or do other security. I think there would be so many less vulnerabilities. I feel like we would be winning this fight against organized crime, against nation states, just other malicious actors that are doing things that are causing our apps and the people that use them damage. Sorry, got a little ranty there, a bit on the high horse. Okay, next question. I get really passionate. Okay, so if an employee learns a trade secret at work and then sells it to a competitor, this breaks which part of CIA? So confidentiality, integrity, and availability. And these next couple questions are all going to be CIA questions. So if one person wants to answer each one, that's cool. They're shorter questions, but I still think it's really important. Does that make sense? So who wants to do this one? Because I'll do it if no one volunteers. Okay.
I try. For the fun. In fact, if an employee, for me, you break more things than the CIA, but I think the first integrity that you broke is your own integrity, in fact.
Oh yeah, that's a good point.
So for me, you break. I will say, in my opinion, you break the confidentiality. Because you will provide to another entities something that is normally must stay in the scope of your company. Integrity, I will say you own, but in terms of data, you will not modify it. You will expose it, but not mandatory modify it. And availability, you will spread. So it will be more available than initially. So it's not the case. But for me, I will say, perhaps I'm wrong, I will say you break the confidentiality in terms of data. But perhaps I'm wrong.
Oh, no, I totally agree with you. I didn't mean the questions to be really, really, really hard. I want the average person to be able to read this chapter and understand the risks they're facing. And gosh, you gave a way better answer than I was expecting. Okay, now I'm gonna have to up my ante a little bit. Okay, so the next question that's on CIA. So if you buy a smart refrigerator and then connect it to your home network, then a malicious actor connects to it and changes the settings so it's slightly warmer in your fridge, and then all your dairy goes bad, so your milk and your cream is just... What would that be? So they don't turn off the fridge. They're not stealing your fridge, but they're changing the settings of CIA, confidentiality, integrity, and availability. Which one would we say that we think they broke?
I guess it would be integrity would be like the answer that we would want to look for, right? Like they changed a setting that they didn't have access to change.
Yeah.
But also, again, on that note, like you can say they broke confidentiality and availability as well, in the fact that like they now have access to whatever temperature that you like to keep your fridge at, right?
Oh, yeah.
They know that information now, because I think Ron brought up a point about the airlines and the what meal type you like, and who knows, maybe someone like me keeping my fridge at like 37 degrees is an attack vector for like something else. I have no idea, but I'm sure someone's smarter than me. But then you also have availability, and it's like, well, like technically it's not. It's still on and running, but if it's not on and running and doing what I want it to do, like it's not highly available, right? It's not keeping.
If it's ruining your food.
Yeah, if it's ruining my food, then it's like it's not available in the state that I need it to be available at. So
your milk is no longer available, Amy says in the chat, which is perfect.
Exactly.
You know what though?
All your milk belong to us.
the infamous like dairy heating attack, I guess.
No, but what about, sorry, Ron, 1 second. So like, you know how right now there's all sorts of different vaccines for COVID, and they're kept at all these special different temperatures. You would be able to tell which vaccine that you are keeping in that fridge, and that could be really sensitive, confidential information. Sorry to cut you off, Ron.
No, actually, you're going down the right way. So I can't say who one of my customers is. It's a top 6 pharmaceutical manufacturer, and I know this quite well, and especially with hospitals. So let's say instead of a smart fridge, well, actually maybe it is a smart fridge, but it's not your home. Okay, it's a hospital or it's a manufacturing lab or a distribution. If you're McKesson, for example, or even if you're packaging frozen meats, right? All of this stuff under FDA, it has to have an intrinsic stamp, and someone's going to say blockchain, and I'm going to throw rocks at you if you say that. But you should have a ledger of all the temperatures. But it's basically, this is the answer I had, but let's assume it's a fridge, and I'll kind of walk backwards in there. So I don't believe in the CIA triad in my industry for the most part, because nobody cares really about password security, for honest. Like the password is company name 123, rocks, like I'll throw rocks at them all day long. But I know why that is, because to change the password often requires a reboot or break glass conditions when it's an emergency and I need to press the red button. So I work in a term called SRP, safety, reliability, and productivity. And that applies much better in this case. So you broke the integrity of the security system because I can't trust the competent controls around my super duper fridge. We've altered the optimal state of the fridge. So we have changed the configuration of it. And I've taken away your milk. All your milk belongs to us, right? And it might not have been there when you needed it. So this isn't really very well for the CIA model, but it's because it's too prescriptive about data security, not about product. And that's why safety, reliability, and productivity is a much better acronym or paradigm to think about this. And so there's multiple steps here, but if we thought about it from a different perspective, safety could have been impacted because of food poisoning. The reliability of the fridge. Let's say I had a child that needed to have milk. Babies. Fine. I don't know much about the subject, so I'm still don't have children. So I guess milk is a very important thing at times. And then the fridge should be closed loop in nature, and you've compromised the function of it. So if you're dealing with real-time operating systems, you've basically torched the system. The operator does not have visibility. And so if you had, let's say, ice cubes, and I kept having it make ice cubes until the machine broke or water was all across your floor, your productivity really could have been negatively affected. And we're talking about vaccines here. Even if the fridge is cool enough, that's why you also have a secondary control of manually testing the temperature of said fridges. But there's been cases where big universities have had to throw out multiple millions of dollars of product, and certain things, certain proteins that are used, like for example, like RNA, or if you're dealing with insulin, some of those proteins and some of those technologies have to be kept cold in a certain way for a span of time, and they have to have every step of the chain of custody measured and accountable. If it is not, you throw it all out and you basically incinerate it. You don't. It's done. It never goes into a human being. That's how it goes in our world. And so when we talk about fridges, I'm looking at it from a totally different perspective. And I hope that's very helpful.
This is why I invited Ron on the show. This is literally why, because of his IoT and specifically like industrial applications of all of these things, right? Because his experience is so different than mine. I was like, oh my gosh, this guy's going to be perfect, because we don't want one opinion. This is, it's funny when people talk about diversity, they're often thinking about different races of people. And it's actually, when we say diversity, we mean different experiences, different backgrounds, and like people that are different races, people that come from different countries. That is part of diversity. But just like I have a public service and private industry type of background, but Ron has this totally different background than me. And I was like, I really need someone who can bring this side of things that I just don't have, I don't have the experience. And so I was thinking of like ruining milk. And Ron's like, well, what if, all of these things happen and then no one gets their second dose of this and then bad things happen and it could cost millions of dollars and more than me having to get on my bicycle, go to the corner store and buy more cream. The implications can be really, really serious.
And it's perceived integrity, right? So just the fridge might have actually been cold, right? At, I don't know, whatever degrees, right? -10 or something. That might be okay. And that's why you have manual checks on it. But because there's a discrepancy in the data and it has to be reviewed by auditors and you'll jump through a whole bunch of hoops and do a bunch of dances and jigs. But if the appearance of integrity appears to be compromised, then you like, for example, if it's an aircraft, the aircraft is having abnormal warnings, even though the plane is still flying, you put it on the ground. Well, that's the same for vaccines. And these are very costly choices that you need to make. And you don't go running and raising the red button and escalating to the CIO. You don't do those things. And I mean, I had to own a $30 million mistake once upon a time. That wasn't my fault, but I had to own it. And those situations, these suck. I don't wish anyone to be in this situation.
But it's our job to protect everyone, right? And sometimes we have to make a decision that might seem severe, but the reason is because that's what we think is the safest thing based on our experience and knowledge of the situation. And it's like, I'm doing the absolute best I can for you. And rather than have people potentially take a vaccine that could make them very, very, very ill, it's like, okay, so you're all going to have to come back in 2 weeks when we've generated new ones, or 2 months. This is okay. I have more questions. Okay, so this is sort of similar. So in Texas, just a few weeks ago, there was a huge snowstorm, and it's Texas, so it's supposed to be very hot. So none of them had all the things so that they could be warm, so that they could live, and some of them were in some pretty serious danger. And I know that because a lot of them, so I'm from Canada, so I know that you can't take wood inside that's pressure treated and burn it. I also know that you can't bring your barbecue inside your house and turn it on for heat because you'll suffocate, you'll poison yourself. There's all these things that I know because I grew up in the frozen Canada, Ottawa. And I now live on the West Coast where if we get snow, it's cute and quaint. But anyway, the point of this is that, so this question is, if someone hacks your smart thermostat and turn off your heat, which part of CIA did they break, and how scary can that be? Ray, you're making this face where it's like, I know the answer, but...
No, it's going to be availability, right? So, like, if it's no longer available to you, then you're going to be cold and it's going to suck. And
yeah. That's okay. A brief answer is totally acceptable because I feel like Ron really detailed it in the last, but I didn't want to not answer it. Okay, let's do the next question. And if you want, you can have first crack at it. So if a programmer adds an Easter egg, which is extra code that's undocumented functionality as a surprise for users, which is unknown to management and unknown to the security team, does this qualify as an insider threat? And if so, why? And if not, why not?
I think it really depends. I think my initial answer would want to be, yes, it is an insider threat, but really it's a lot more gray than that. I think there have been a lot of great Easter eggs in the history of software that were not malicious, that were... I can't think of any off the top of my head right now, but in like video games, just software in general for office software, there has been hundreds upon hundreds of them, and they were fun and enjoyable for a lot of people. And I think it really depends on what that Easter egg is, and it really depends on what that surprise is, or if they're subverting extra functionality that is like security controls or something like that to put in this Easter egg. That's where it's kind of gets more into their insider threats. Also, like intent, right? Intent is very important. If they're doing it on purpose as being malicious, then like, yes, terrible. It's an insider threat. If like generally you shouldn't do it, but like if it's your own application and you're doing it for fun, like as long as you're doing it safely, I don't see any harm in it, you know. But you should probably let your manager know because they're the ones paying you to build that software. And software's in the 90s was built a lot differently than it is today, right? Like there's no like software cowboys anymore like there used to be. So that's kind of my long-winded answer.
Does anyone else want to weigh in?
Yeah, I have a story with an Easter eggs, but it did not mean that I have had it, but I have see it in the middle of the expected date. So several years ago, I was working for as a developer, and in December, and at the moment in December, we saw snowflakes on the web application. Merry Christmas and so on. So it was cute. So they, to be honest, no issue. It's well designed, beautiful. But even if the development team was found this snowflake very amazing. The management was not in the same mood. So it started to be a huge mess because people want to find who had this code, and we dive into the SVN because at this Git was not so popular, and SVN deep dive who is the people that had this because it was a different team, and when we spot the commit, we found the people has leave several months ago and work for another company. So it's become a huge mess. But a huge mess, not at the dev level, not at the technical level, not at the client level. It was only a mess at the management level. So it was a mess in one office, in fact, to be honest. So we spent more time to explain to management. It was fun, no problem. Customers was laughing at all, so it was okay, in fact. And but we spent more time to explain to management. It was not a problem, just a fun fact that to explain to clients that it was okay. So for me, yes, you can add Easter eggs if you want, but document them. Made it clear for the team. Document them, but you can add the Easter eggs. It's not the evil. And but like any feature, document them, make code review on it, on them to be sure that it's secure. Let's go, let's fun.
Ron, do you want to weigh in?
How do you know? So pragmatically, there's two types of insider threats, and there's accidental and malicious, right? And malicious can be disgruntled persons. It even could be the abuse for a third party. There's some sort of attribution there that's a bit tricky. But if you're a programmer putting in code, I waved my phone earlier because my Google phone usually has games hidden in one of the menus. So or a debug mode if you tap the version enough, right? So there is I call them dead bodies. That might be as a PC, but there's skeletons in the closet in a lot of stuff. So in the case of a developer adding an Easter egg in a video game, like a stack of skulls or something, I don't know, whatever. If we're thinking old school, right? That's more on the accidental side if there was something negative here. And I comment on LinkedIn, Lance Villian is my old school name. I'm actually from out west in British Columbia, not in Montreal. But we need to think about things about, okay, you put something in there and it results in a vulnerability. And Benjamin's kind of alluding to the same thing here is, if you're in an industry where things, even if you did it accidentally, there's complications of if an event or a breach occurs, then you will have to own that. There might be legal issues with that. So if you're banking information, I don't know, you shouldn't be putting Easter eggs in a bank app, but maybe you wished and you did. If it's Christmas time, you added snowflakes. But this can tarnish the organization, which means you get fired. And it means that you might have indemnification. Indemnification is not a fun process to go through. It is very expensive. How many of you as freelancers have insurance? I bet you don't. And you don't have it, even if you did, you wouldn't be in the business because you wouldn't be able to afford what it actually costs. This sucks. Like, I really mean, like, for $1 million indemnification, which is nothing in terms of liability, you're talking about something that basically you might as well not have it because you're going to be losing your house anyways. Because you were negligent. Automatically, you were negligent. And I would love to tell a few industrial vendors that too, that they've been negligent in the past, but I'm not allowed to. But you really need to be careful because you did something that was not required or expected by your job role. And you've breached all of the policies and all of the things you've signed, and you need to be very, very strictly careful. And now Canada's a bit more careful. In Europe, you basically can't, in some places in Europe, you can't be fired for anything, no matter how hard you tried. But in Canada, it can be tricky. The United States loves to go through legal hoops and boundaries. So I highly recommend that people don't add GIFs into code unless you want to own them later.
Yes. I personally consider it an insider threat because you did a thing and you hid it from management, and that code's not going to have security testing on it. That code's not going to have a secure code review. That code would not have been threat modeled. And so the level of security of that code is significantly lower. I also think that you intentionally hiding something from your manager and releasing it into production is malicious. Even if you're like, oh, it's a joke, it's this, it's that. It's like, no, you intentionally hid something from. So I actually had this happen to me, and I'm not going to give the specific example. And it was that someone had added a bunch of graphics. They'd added just like a few that they thought would be fun. And the person thought it would be cute and fun. And I was like, that doesn't match our branding. And I don't want to have a surprise. And I appreciate that this person had not studied computer science, and so they hadn't had any of those ethics trainings or any of those things. And I was just like, I need you to take those all out now. And they had told me before so many things could have happened, right? But it went out, and then I have, customers coming to me about my app, and they're just like, oh, it's weird how you have all of, so at one point, and it was cute, it was positive things, like at one point, all these hearts came out of the screen. Well, they're the wrong color. They didn't match any of the other colors in the whole app. So then it was like, it looked really weird and off. And I was like, just tell me your awesome ideas and then we'll do them. You don't have to hide them, right? And we came to this nice compromise and everything worked out really well. And it wasn't malicious. And they told me before the special day where things go live, but it's just like, what if the person had added something and then that code was vulnerable and then really bad things happened and all the egg as the manager of this project's on my face, right? Like our organization could be in serious trouble. I mean, I consider it malicious even if, because you're hiding it. Do you know what I mean? When you talk to your parents, if you are on purpose avoiding a thing like this, it's because they're going to be ticked off at you or unimpressed with you or be like, Tanya, stop cutting trees down on your own property because you're going to get hurt. Why don't you stop being so cheap and hire lumberjacks? Which I did after a branch landed on me. But the point is, but my mom's like, you seem to have skipped telling me that part where the branch landed on you and your cousin told me. I'm like, oh, I'm in so much trouble even though I'm in my 40s. But yeah, when you're hiding a thing from your boss, like that's a big deal. And I don't mean, I don't know, like a big feature that you're, anyway. So I have strong feelings about this and I would be like, I think you're pretty fired. Don't let the door hit your derriere on the way out, or do, I don't care, you get out of here. I'd be pretty ticked as a dev lead if my dev lied to me like that. I would feel hurt.
So in fact, I want to clarify my perhaps the thing that I said. Even if I said that's fun and so on, so it's clear that the code must be if you want to add an Easter egg, okay, you can do it, but do it like a normal feature with following tests and so on. So you can add, for example, you can add Easter eggs, but Easter eggs is a feature. Easter eggs, it's a feature. It's tested. And Gary made a very interesting remark because it's adding an Easter egg or something like that can be also a test to see if your security checks, for example, can spot it. Can be, for example, you say to your manager or your security department, I will add this line, for example, people are aware that you have had this kind of things, but it's a canary, if I can say that. It's a canary. If I try to make the parallel, you made a canary and say, okay, for example, you can help to evaluate the companies you hire to do a code review. For example, you hire a company to do a big secure code review. You say, okay, I will give you, for example, branches of my Git repo, but it's in this Git repo I will add some kind of Easter eggs but undocumented, and you will see if they spot them. Can be also a test. So to summarize, yes, if you want to add an Easter eggs, document them like a normal feature and less fun. In using this way, you can add design and so on, but document them like a feature, and you can, like Gary said, you can use it as a canary to test your defenses, your detection system, like you will do, for example, for your virus and so on.
Yes. I also, I guess I want to clarify too, when I say Easter egg, like in the question, I'm like, it's extra code that is undocumented functionality and it's a surprise for the users, but also is unknown to management and the security team. I love the idea of making an extra feature that's a surprise for users, as long as it's been properly security tested. I feel like I'm a grouchy pants saying that, but I don't care.
There was some interesting concepts, especially with you cutting down trees. Sorry.
Oh, no, but like, I don't want to be surprised as the security team. I want our customers to be delighted and surprised and have fun, but I don't want to be surprised.
I was chuckling at the way you're talking about how your mother was questioning, whether or not you should be lopping down trees. And because Dominic's got a really ironclad face and his eyebrows don't move much unless he's very into the moment. I learned once upon a time from a really good secondary high school teacher for my computer science way back in the day. This concept of does your grandma would whatever you're doing raise your grandmother's eyebrow. And I stick by this. Like if your grandmother, even if she doesn't understand what we're talking about at all, if she would question what you were doing, then you probably shouldn't be doing it, or you should ask for help. So that was what I wanted to say on that particular thing. And then I was kind of thinking, well, we've only been focusing on technology and let's say process in the PPT, people, process, and technology method, but we haven't talked about training. And I mentioned, I'll clarify my comments, or a tabletop or a choose your own exercise. This is a really good soft exercise to have your developers go through as a team building thing to maybe this might actually elicit the fact that you have dead bodies hidden in your code de facto, because someone might be like, yeah, actually that guy that left one for us, or, oh, I did that the other day, was that not allowed? And so you can get to consequence and corrective measures without pointing fingers. And I think that's something we haven't talked much about, but there's a lot there.
Oh, I love that, Ron. Oh, you're so good. You bring up so many good points. All of you have been so great. Okay, we only have 2 questions left, and since we're at the 2-hour mark, that's probably good, because I had several cups of caffeine and then this entire bottle of water, so that's going well. Okay, so second last question. When connecting to a public Wi-Fi, so this is a general good hygiene answer and I know most of the people watching are probably security experts and they all know this, but in case because this is the security fundamentals chapter, right? This is the chapter anyone can read. My grandma can read this chapter. Also my grandma rules. But anyway, when connecting to a public Wi-Fi, what are some of the precautions that you could use to take to ensure you are doing defense in depth of yourself and your own computer? What could you do? You could connect a virtual private network. You could turn that on your phone so that you tunnel through the shared Starbucks VPN. Nancy and I love Starbucks.
It's boring. You can run a map, scan the network, and see open port, and let's play.
I don't know if that's defense in depth.
Yes, for the fun, you scan, they scan you scan them. Yeah, you try. It's like a chat, but use the TCP, UDP, and so on. You start discover something. Yes, let's fun.
Also, maybe if they have the default admin passwords, then you could just patch everything.
Yes. If you want to play, in fact, you start a Docker container. For example, you start up a WordPress with default create in a container without any access, and you check the access log for the fun, and you see people connecting, trying to stuff and so on.
Okay, so I'm not suggesting we sniff traffic at public.
No, I'm joking. I made a troll. I'm joking. It's a pure joke. Kids don't know this at home. No. It's a joke. It's a Saturday night. I want to joke. No. You will go to jail. So no.
Oh my gosh, you're awesome. Does anyone want to add more things that you could do?
I can't remember the last time I connected to a public Wi-Fi anything, truthfully. But I mean, don't go on like your banking website on public Wi-Fi. Don't go on anything important. Like if you have to use like information, like look up information for stuff, like use like HTTPS only websites is a good thing. The VPN is, I don't like VPNs personally. I use them for work and that's about it. But if you have to go on a public Wi-Fi, VPNs are a pretty good choice. Yeah, like avoid them if possible. Like use your mobile network, or like if that's available to you. That's not available to a lot of people. I just choose not to be without internet if that's my only choice. Like I don't need to be online that much. If I can wait to Google something once I get home.
Yeah. You could also so like my web browser, for instance, there's a plugin HTTPS everywhere, and it just only lets me go to those sites. That's another thing you could do to make sure you don't accidentally go to an HTTP website. That's another layer of defense you could do. I also always use DuckDuckGo rather than Google, unless DuckDuckGo has failed me, which is very, very rare, and usually when I'm looking up really obscure things. But that's mostly just because I don't like Google spying on me so much. Also, that's why I got rid of my Fitbit. I've ranted a lot about my Fitbit on the internet and how sad I was to break up with it, but that's more about privacy. But does anyone else have any other suggestions other than one? If you can avoid it, just don't connect to public Wi-Fi's.
I have
Yeah?
another remark in addition to the Wi-Fi, because I see in my customer, I see friends and so on. I see often people in their company, for example, they are on their work and connecting to their bank. And I said to them, "Do you have checked the certificate? Does the certificate is the one from the bank? Because when you use a company device, laptop and so on, it's normal they install certificate authority on your laptop in order to be able to inspect the traffic. So they see all the traffic all the traffic that goes through your browser. So if you connect to the bank, Facebook, and your private life using your professional device, the company will see your traffic. Alors, yes, normally they do not, they are not allowed to use them and so on, but you are not technically you can be confronted to someone that access to the log and so on and can see the information. So in fact, when I use my for example, when I use my connect to a personal site, I check the certificate to be sure that it's a real certificate and not the one from the company. And when I use a mobile device, I'm a big fan of the certificate pinning. I put the mess every time, but I'm a big fan of the certificate pinning.
There's a lot to be said about this.
Someone made a comment in the chat and they were saying use WhatsApp or Messenger app for essential communication, but I would say no. I would say so I use Signal. I don't use WhatsApp because it's owned by Facebook, and I don't use Messenger because it's owned by Facebook, and they spy so much and they use all my battery. And but battery aside, yeah. Oh, hi Jet. I didn't know you're there. My friend came on. I feel like I don't need Facebook to know everything about me. I recently had to make a Facebook account because my marketing team forced my hand. But if you want to speak to my interns, you can message me there. If you want to speak to me, you can talk to me on Twitter. But like, I don't like a lot of the things that I see the Facebook company doing, especially in regards to privacy. That whole thing with Cambridge Analytica freaked the pants off of me, and they're from the city I live in, as our unfortunate anti-thesis claim to fame of Victoria. I don't appreciate those things. So there's no way that I would send my sensitive information on WhatsApp or a Messenger app or ever install Messenger app or Facebook on my phone. My phone has never had that on there. And it did have WhatsApp, but only because of all my friends in Israel. But I broke up with it months ago when Facebook changed its terms of service for WhatsApp. And they're like, yes, actually, we will be taking that data. And I was like, goodbye. And I even convinced my dad to install Signal. And he's 72, turned 73 this summer. And so if my parents can install Signal, so can you. I'm sorry, I'm really on the high horse. But I was just like, oh, I must address that. Okay, does another person want to talk who's not me? Sorry.
Sure. So we've only talked about the communication tunnels and what you should and should not put through those tunnels. And there's another aspect too. So we've only been talking about outbound network-driven connections. We haven't talked about your surroundings. So shoulder surfing, how many times when I'm flying across country? So to give you an idea how much I flew, with Air Canada alone in 2019 before the lockdown, I did 75 flights just with them alone. I went to Japan for 2 days, direct flight to Montreal, just to give you an idea of how much I travel. And I can't tell you how often I see spreadsheets with very large Fortune 400 companies with their gross revenue and actualized revenue on a PowerPoint slide in front of me. And I just chuckle. because that could mean a lot of things to a lot of different people. But we're only talking about situations. Now, if you ever lived in Vancouver, you know that there's a very large transient population. It's a very, very big challenging issue that we have on the west coast of Canada and the United States. And when you're in a coffee shop, one of the things they like to do is to go hawk your bag, because you just leave it at your feet and you go to the bathroom, or your cell phone. In Montreal, they love to leave, the students leave their stuff everywhere, and professionals, and I don't understand this trust system, but that's a big issue there. Make sure your devices are powered off and not in suspend mode. Those are other things that you should be doing, because then when they go to boot up, and if you have hardware encryption on your disks, or boot pairings between like the secure chips inside of your platform, at least you're making it really hard for your average thief. Now, usually they just format your system and walk away with it. But my phone got stolen in Mexico City, and guess what? They actually managed to find a cache collision, and they logged into my GitHub account, and I was chuckling so hard because I had nothing in that GitHub account. But I thought it was hilarious. They did manage to get into my phone. And that was one of the things I forgot to revoke. So there is other aspects there of what's through the tunnel, your surroundings around you, but also coming towards you from inside of the coffee shop. Do you have your system patched? Do you allow RDP connections to your laptop or SSH? Is your firewall on and denying everything that isn't the result of something originating from your system? Those are all things there. And then I saw someone talking about self-signed certificates on web pages. Those are all things there to consider, or which service did you use, like don't use FTP and so on and so on. Or you don't want someone snarfing your cookies and getting a sequential login as well, right? That you can do ferreting. There's all sorts of stuff here. Or use YubiKeys and FIDOs to help make your life a lot better. And that way there isn't a password ever being seen on a CC camera TV feed behind you. By the way, that's a great attack vector. How many of you think about covering the last 4 digits of your credit card when you press the tap? You don't. I do. There's all sorts of interesting aspects that we haven't quite talked about. Yes, I know they're not app security, but they are, because you can indirectly compromise your own organization and your app.
And all of these things matter, right? Yeah, I've heard of quite a few places skimming credit cards and then using the video cameras to watch everyone put in their PINs. And it's obviously an insider threat when that happens, but gosh, that's really bad. And so I'll be getting gas and I'll put my hand over and people are like, oh, do you think I'm going to steal it from you? And I'm like, I don't want anyone to be able to steal it from me. Oh, I'm frozen in such a good place. Ron, that is a great answer. All of you. And in the chat, so many awesome comments. I was tempted to just read all of them. And then I was like, okay, then the show will really be 3 hours. We have one last question that I am going to kick off. And so it's a bit of a janky question. It's not super great. If you live in an apartment, so when we say identity or factors of authentication, we usually mean electronic, like a computer identifying you as a human. So let's pretend that an apartment is computerized. So if you live in an apartment with several roommates, so besides being unhappy and everyone eating your food, but if everyone all has a key to the door, is that key, if you have one of those keys, is that considered a factor of authentication? What do we think on that? It's hard,
put yes.
Right? Mm-hmm. Do you want to elaborate a bit?
No, I'm just joking. I don't think it identifies you as a person, but it may identify you as a roommate, assuming that if there's 4 keys and only roommates have keys, because I read the answer on yours and at the back, and the only thing I would say about that would be I believe you talk about I think it can identify you as a member of a group, right? Because having a key is not I think it's more authentication than it is authorization, because authorization would be do you belong here? And just because you have a key doesn't mean you belong there, right? So yeah, I would say it kind of makes sense to look at it as authentication. in a way, I don't know. This is a hard answer. This is a hard question.
It is, right?
Like, it's not super straightforward or simple. But I would say, yeah, like I have a key. I am an owner of a key that can enter this house. So like I'm kind of authenticated, or okay. I don't know.
It's a messy question, right?
Yeah.
When I wrote the book, I wasn't supposed to have an answer key. You were supposed to have to come to these streams. But then my publisher was like, no, of course you're putting a darn answer key in there. And I was like, yes, sir. But like Mario points out, you could lose the key, just like you could lose your password due to credential stuffing. Someone pointed out choke point theory and kill rooms. And I'm not exactly sure what kill rooms has to do with it because I don't. Okay, we'll just leave that. But choke point theory, I would say the idea is only this many people can get in. And then hopefully if you have several roommates, someone will be like, hey, who's that person? Maybe they don't belong here. They're eating all the pizza, which as a Canadian is a huge offense.
Yeah, so that was me, by the way. So let's say, for example, maybe not as a room or a house, right? So let's say we're the Canadian border, which is the largest unmanned border in the world. And so, and I'll fake my really super duper Canadian accent here. So we have this American, and he's like, oh yeah, like I'm a Canadian, and I really, really know what's about up there. Eh? That person could just be in there and pretending, right? It is a factor as like if you use the DMZ, if we're talking about networking infrastructure, or a place where you should put all your undesirable things you don't care about, where multiple people might access it. You try to strain the people getting into it to an audience that at least you can apply a certain level of scrutiny upon. Right, so you get in there, and then the security guard comes and says, "What are you doing here?" And then you have to produce some sort of credential that is probably more substantial. Like, for example, if it happened to be a roommate with lots of people, it's super weird, but you'd have like a lease entry, or I don't know, making this up. But you basically you started with a wide net, right, like a pit mine, and you've pushed everyone down into a smaller area where you can apply a more subservient way, and so you have less bycatch, as if it was like a fishing analogy. So it's just a form of perimeter security, but then it further increases the importance of further security investments and vigilance on the zones and segments within that premise, or that could even be applications or a logical construct. So it's much, much more than that. And so when I said kill rooms, right, a kill room is a box that you control the group of. So a kill room might be the lobby of a building. So yes, you can get into the lobby, but to get into the elevator, some of us have seen this in government buildings. You can't get into there without getting someone, really, really giving you a hard time at that elevator, for example. And Tanya knows exactly what I'm talking about. So the elevator and the area around it in that case would be a kill zone where they can come get you and double check whether or not you should be there or not.
Someone commented that the Canadian border is so unguarded that joggers cross into America by accident somewhat regularly. And also that pizza thievery is an offense in every place, not just Canada. Also, lots of us are going for beers with Jet as soon as the COVID's over. That is a great answer. Ray or Dominic, do you want to add anything? Because I feel like we've hammered this question pretty good. Okay, so there's one question from Gary in the audience, and then we're going to wrap up. Does this work for everyone? Okay, so Gary's awesome, by the way. So interesting, the split opinion on the key being a factor, but we wouldn't argue that a U2F key isn't one, so like a UB key, for instance. So is that because of the crypto involved or the uniqueness of the key? And I would say the reason why we're confused is the uniqueness of the key. But I like how you sussed that out in a way so it was so clear. What does everyone else think? Is it because of the crypto or the uniqueness of the key?
For me, if I'm not wrong, I think you can in U2F key you can also add a passphrase. I think you have one if you much touch them, and you have I think you can also add touch plus passphrase and so on. But I don't remember, but if I'm not wrong, I think if you can add a touch passphrase, you have something that you know and something that you have. So for me, it's become some kind of two-factor. Even if in final they are linked into one device, because the things that you know belongs to the device. But for me, as you need to have the key and the passphrase, for me, it can do the job. And there are two-factor.
I love all the comments. I really appreciate everyone coming. This has been absolutely spectacular. And the discussion with all of you, Ray, Ron, Dominic, this has been so, so, so great. I want to thank everyone for coming live. I want to thank everyone who's listening, who was, who's listening later or listening now. And so my book, Alice and Bob Learn Application Security. If you don't have a copy, obviously you need to buy one for every person you know.
My company buy 50. 50,
Oh my
50,
gosh,
50,
that's
50,
awesome.
50, 50, 50, 50. Yes.
That's awesome. That's so amazing.
In fact,
I want to.
my boss, I order 50 and try to distribute to customer as a gift.
Oh, that's awesome. If I haven't already got you in touch so that you can have a deal, let me know. If you buy in bulk, I can get you discounts. Oh, thank you, Benjamin, Adam, Jet, Andrea, Megan, Adam, Benjamin, and Ben, and everyone else that's on the stream. Thank you, Ron and Ray and Dominique. I really appreciate all of you, and I think we should wrap up. Next month is going to be in 4 weeks from today at the same time, and we're going to do chapter 2, which is security requirements. And I know that some people might not think that security requirements are super exciting, but I do, because this is the furthest left that the average person can get in the system development lifecycle. If you set up requirements for your app, for your API, for your IoT device, for that special smart fridge that you're making to hold that medicine so it can save lives, this is you setting the stance from the very beginning that security is going to be there the whole way through. And so we're going to talk about different types of security requirements. And I know that my friend Nancy's coming on, and I believe, Ray, are you coming? Dominique's coming. Yeah, Ray's not coming, or maybe he is. And we have another tentative guest. I kind of just drag Ray into things against his will, but he's very, very good about it.
I am the fill-in guest.
Thank you so much, everyone, for coming. I hope the rest of your day or evening goes totally awesome. And I hope to see you in 4 weeks so we can learn even more together with Alice and Bob. Thank you.